Okay, this is Mr. Peterson finishing off the 8-5 notes. This is page 4 of 4. And on this page we have 3 practical problems. One of them is about, this first one is about population of some endangered birds. The biologist has a way of estimating that there are about 5,350 of these birds at the start, but unfortunately they're decreasing by 2.8% per year. So you can see the calculations up there to figure out this base of 0.972. And he or she wants to know when this 5,350 will finally decrease to a more critical level of only 3,500 of the species left. So we're going to solve this algebraically, and then we'll check by solving. First thing you want to do here is divide both sides by the 5,350, and that'll put your base by itself. 5,350. Okay, that cancels that. Now I'm going to unravel this. The log base 0.972, that's really weird, of this equals t. So log with this strange base, then you come around and pick up this number over here, 3,500 over 5,350 equals t. So it's really just a matter of typing this monster in. So bad. Math alpha math 0.972, and then you got to go 3,500 divided by 5,350, and that, ladies and gentlemen, is 14.9 years. So this species is going to be in more critical shape within about 15 years here. Let me put the full thing here. I don't think it needs that much accuracy, but there you go. Okay, now we're going to just kind of figure out this problem the other way. So I'm going to go back to what I originally had written here and type in 3,500 for the first function. And then on the other side we had 5,350 times 0.972 raised to the x power. Okay, I know that this thing is starts at 5,350 as my y-intercept, so that's really high up, and this line that's going to be drawn is at about 3,500. So I need to take this window and make this around 6,000, and let's see what 30 years of this will do. So there's the line that tells me it's much more critical. And here's these birds, fewer and fewer of them, and I want to find that intersection. We should get this answer. Second calc, choice 5. Move your cursor over near it and hit enter 3 times. And your answer pops up right there. Same answer. Okay, half-life problems. You got to be careful not to haul the I don't know if that's a neutron number or proton number or something, but the cobalt 56 just designates which type of cobalt, the molecular structure of that particular isotope. All right, so the half-life is 77.3. You put that underneath there. I've got the wrong number there. 77.3. And how long will it take an initial sample of 60 to go down to 40? Half-life problems always use a base of a half. Now we're going to start by solving algebraically here. Divide by 60. And I'm going to go ahead and call this 2/3 in a minute here. 2/3. Now I'm going to go log base 1/2 of 2/3 equals that. And again, the 2/3 is just as 40 over 60 simplified. So there's your base. Come around, pick this up, and come around on the other side. You get t over 77.3. Now all I have to do is multiply both sides by 77.3 to cancel that off, and it's just number crunching at this point. So let me go to my home screen. 77.3. And then I set up my logarithm here with a base of 1/2. You can use 1 divided by 2 or 0.5. And then inside there you want 2 divided by 3. All right, I'm going to check this. Store for x. Well, we're going to check it the other way, so never mind that. All right, so 45.2 years. Are these years or days? Oh, these are days. Okay, so 45.2176. A little bit of overkill to use that much accuracy on this problem, but that's days. Okay, solved by graphing. I'm going to go there and type in the goal. We want to be down to 40. And we start with 60, but it's got a base of a half, so you know it's going to be a decay problem. And put your x divided by 77.3 right there. Alright, a y-intercept here of 60, a line at 40. I'm going to take my window and put this at 100. Alright, let's see what going out to 30 does for us. I don't think it's going to be enough. I think that's going to come right close to intersecting. Yep, we got to go up further to the right, so I'll make it 50. And here it goes. I should have known. It says 45 right here. At any rate, it's going to cross now, way over here towards the edge of the screen, but it is crossing. Second calc, choice 5. Move your cursor over near it and hit enter 1, 2, 3 times, and there's your same answer right there that we just confirmed. And by the way, you also know that it's at 40 at that point. Okay, this last one here is a little girl named Cindy, and she gets $4 a week starting her kind of spending money, and that allowance is going up by 15% per year because her daddy thinks she's really sweet. So here's the base. You take 100% plus a 15% raise every year, and this is the percentage, and there's your base. So you see I put that there, and I also put the initial value right there. So we're just going to do a table of values to solve this. How long will it take to be north of $10 allowance per week? So I'm going to just type this in here. Give me a second. 4 with a 1.15 base. And let's set up our tables. I'm going to start right at the start. Actually, I'm going to start at 0. And automatic mode. Okay, that should do it. Well, it's a little hard to see with all these zeros here, but you can see that the wages went up to about $9.25 by the 6th year. So if I scroll down there, I think it's one more year down, and I'm already over 10. So 7 years is the answer. And that does it for the notes for section 8.5 and algebra 2.